Do subscribe to Ekeeda channel and press bell icon to get updates about latest engineering, HSC and IIT JEE main and advanced videos.
As mentioned in your screen, there's a question or there's an equation which is based on the balancing the redox reaction in basic medium. So the above equation which is present on your screen is not actually balanced, so we have to balance. Again, the difference between the acidic medium and basic medium is it will follow the same step until and unless an extra step will be involved in the last step. So what are that step or what are those steps? Let us see. So the first one will be, as we know, that in step number 1, that is determination of oxidation number. So we have to determine the oxidation number of each reactant as well as the product also. So in this case, the first reactant is zinc. So in zinc, as we can see, there is no charge on it, present on it. So therefore, I could say that the oxidation number of zinc which is present in the reactant is 0. So therefore, I could write it in this way. The oxidation number of zinc is 0. Now moving towards the next reactant, that is NO3 minus. So let us find about the oxidation number of nitrogen present in NO3 minus. So for NO3 minus, which is the -1 charge, the oxidation number of this molecule is -1. Why? Because as we can see, this molecule consists of a -1 charge. So therefore, I could write it as the oxidation number of the molecule, that is NO3 minus, is -1, or I could write it as 1 minus. But in this case, we have to calculate the oxidation state of nitrogen, because the oxidation state of oxygen is already known to us, that is -2. So therefore, in this case, I could write it as 1 into nitrogen, because nitrogen is present 1 times, plus 3 into oxygen, I'll write in the form of oxy, and the overall charge is -1. So therefore, I could consider the oxidation number of N as X, as I don't know, for an instance, and 3 into oxidation state of oxygen is -2, or I could say as 2 minus. So therefore, the answer would be 3 to the 6, but in this case it is -2, so therefore 3 into -2, that is -6. So this -6 will shift over there and it will convert into +6. So therefore X will be +5. And ultimately we could write the answer as the oxidation number of nitrogen in this nitrate ion is 5 plus. So the reactants has been completed. We have determined the oxidation state of the reactants, but the products are also remaining. So we are now heading towards the determination of the atoms which are present in the product molecules. So in this case, the first product was NH3. So therefore, for NH3, the oxidation number of NH3 is 0, as we are observing that there is no charge present on this molecule. So therefore, I could write it as 1 into nitrogen plus 3 into hydrogen, or 3 times hydrogen, which will be of 0 oxidation state. So therefore, I could consider the oxidation state of nitrogen as X, plus 3 into oxidation state of hydrogen is always 1. So in this case, I could consider it as 1. So therefore, the value of X in this case is -3. So for this case, I could write it as the oxidation number of nitrogen in NH3 is 3 minus. This is the first product's oxidation state of the nitrogen that we have calculated. Now the second product is also remaining, and the second product is ZnOH 6 times 2 minus. So for this thing, what we are going to do is we are going to determine the oxidation state of zinc. And let me give a short recap that the oxidation state of OH, that is the hydroxy group, is nothing but -1. So we could take it as -1 as it is. So we don't have to calculate the separate oxidation state for oxygen as well as separate oxidation state for hydrogen. We can ultimately make the oxidation state of OH as -1. So therefore I could write it as the oxidation number of ZnOH 6 times 2 minus is 2 minus, that is -2. So therefore I could write it as 1 into Zn plus 6 into OH hydroxy group, which will give an overall charge as -2. Therefore I would consider the value of the oxidation state of zinc as X, plus 6 into, as I said, the oxidation state of OH molecule will be -1. So therefore this will give me an answer of -2, while this will be +6, and overall I have got the answer as 4. So therefore I could finish by concluding it that the oxidation number of zinc in ZnOH 6 times 2 minus, or I could say it as zinc hexahydroxy ion, as 4 plus. So this is how we have calculated the oxidation state of the atoms which were present in the reactant as well as the product molecules. So now on the basis of this, we are going to check whether the reaction is a redox reaction or not. So let us see how can we determine that. I'll write the reaction as it is, which was present in the equation, which was Zn, that is zinc, plus this nitrite ion plus ammonia, plus that has given you ZnOH 6 times, and this is 2 minus. This was the reaction in which we have evaluated, or we have determined the oxidation number of zinc as 0. The oxidation number of nitrogen in this molecule was found to be 5 plus, while the oxidation number of nitrogen in ammonia was found to be 3 minus, while in case of zinc in this molecule, that is ZnOH 6 times, or zinc hexahydroxy ion, has given us a oxidation number of 4 plus. So let us see whether the reaction is oxidation or not. So in this case, if I compare the oxidation number of zinc, it is changing from 0 to +4. Changing from 0 to +4, it means it has lost electron, and the process in which electron is lost is known as oxidation. Now in this case, I will compare the oxidation number of nitrogen. In this case, it is changing from +5 to -3. +5 to -3, it means, first of all, it will gain electron to convert into zero oxidation state, and after that it will gain more electrons to convert into an oxidation state which is going towards the negative value. Means ultimately the electrons are being gained in this process. So the process in which electron is gained is known as reduction. And hence finally we have determined, or we have made a final statement that this equation is a redox reaction. So with the help of this, we are going to move towards the step number 2. And what is step number 2? Step number 2 is balancing the electrons. So let us see how much electrons are being gained or how much electrons are being lost during this process. So the step number 2 will be, I would name this step number 2 as balancing the electrons. In this case, as we know that the number of electrons are being lost during oxidation, so I would write it as the number of electrons lost during oxidation, while as we know that the number of electrons are being gained during reduction. So therefore the number of electron lost during oxidation is, let us calculate it. So as we can see, the number of oxidation state, that is the number is changing from 0 to 4. It means how many electrons would have been lost during this process. Exactly, 4 electrons would have been lost during this process. So I would write it here as 4. While conversion of +5 oxidation state to -3 oxidation state, the number of electron gained will be how much? I'll give you a rough idea. If +5 oxidation number gains 5 electron, means ultimately what would be the oxidation number? Yes, it would be 0. So but we have to take that 0 value till -3. So again for that we have to take 3 more electrons. So ultimately we have taken 8 electrons to convert the +5 oxidation state to -3 oxidation state, as you can see here. So ultimately we have taken, or the electrons that might have been gained during the conversion of +5 oxidation state to +3 oxidation state is 8 electrons. But as you can observe here, the number of electrons gained and the number of electron lost, the both are not same. One is 4 while the other is 8. I could make it a balanced one. How? If I multiply this equation or this reaction, oxidation reaction, by 2, and I'll keep the reaction of which is showing reduction as it is. So in this process what I have to do is cleverly that we should multiply the oxidation, the process who is involved in oxidation, by 2. So our earlier reaction was this one. So finally we have evaluated that we have to multiply the oxidation reaction by 2. So in this case, which one is showing oxidation? Exactly, zinc is showing oxidation. If I multiply this by 2, eventually this whole equation or this product will also be multiplied by 2. So I would get the answer as 2 times zinc, or 2 moles of zinc plus NO3 minus, that should give me NH3, plus again 2 times ZnOH 6, 2 minus. So this is how, or this is what we have been calculated the balancing of electron. So let us move further. So this was the second step, and the step number 3 would be, yes, calculating the oxygen atoms. So the step number 3 will be balancing oxygen atoms. So in this case, as for the previous reaction, as we could see, the number of oxygen present on the left hand side or present on the reactant side is 3, while that in case of the right hand side is 6, but it is multiplied by 2, which means 12. So therefore I could write it as number of oxygen atoms on left hand side as well as number of oxygen atoms on right hand side. As for left hand side it is 3, while for right hand side it is 12. So friends, as we can see that there is deficiency of oxygen atoms on left hand side. So what we have to do? Again the same thing that we have did in acidic medium. For this case we will add H2O molecules on the deficiency side. So in this case the number of oxygen atoms that are deficient are on the left hand side and with a deficiency of 9 oxygen atoms. So because here it is 12 but here it is 3, so there is a deficiency of 9 oxygen atoms. So for that I would give a statement as adding 9 moles of H2O on left hand side reaction, or that is on the reactant side. So because of which the balanced reaction that I have got earlier will be same as it is. There will be a difference of that. Here it would be present 9 times H2O. So I would write this reaction as it is with a few change, that is 2 times Zn plus NO3 minus plus 9 times H2O, and this would have been giving me NH3 plus 2 times ZnOH this side. So this is the step number 3 that we have written. So we are moving towards the step number 4, and that is balancing the hydrogen atoms. So the step number 4 would be balancing hydrogen atoms. So in this case we will calculate that how many hydrogens are present on the left hand side. So here in this case I would write very shortly that the number of hydrogen atoms on left hand side, while the number of hydrogen atoms on right hand side. So as if we calculate for the step number 3, then the number of hydrogen on the left hand side is 9 2s are 18, while in case of right hand side we can see there are 6 hydroxy group, so therefore there will be 6 hydrogen, but this is for 2 moles now. So therefore 2 multiplied by 6, which is 12, plus as we can be careful, but in this case we can also observe that there are 3 hydrogens in ammonia molecule. So therefore for this case it is 12, agree, but for this one it is 3. So 12 plus 3 it makes 15. So therefore there are 15 hydrogen atoms on the right hand side. So in this case we can observe a deficiency. There is a deficiency of hydrogen atoms on the right hand side, and how much? About 3. So therefore what we are going to do, adding 3 H plus ions on the right hand side or on the product side. So the answer that we could get is as we can observe, step number 3, it will be the same as it is. The only difference would be here there will be the addition of 3 times H plus sign. So therefore the answer that I could get is 2 times Zn plus NO3 minus plus 9 times H2O. Again this will give us NH3 plus 2 times ZnOH this ion, plus as I said I have to add 3 times of H plus sign. So I am adding 3 times of H plus sign. So by observing this, the hydrogens are being balanced as well as the oxygen is being balanced. But this is not the ultimate answer. We are deriving or we are balancing this reaction in a basic medium. As you can see, there is a presence of H plus ion, which means it is now in acidic condition. So how can we turn into basic condition? For that only I have said that there is an extra step. And what is that extra step? We have to add OH minus on both the sides. Let's see how. So let me tell you that to neutralize this acidic H plus, as there are 3 moles of H plus as you can observe here, so to neutralize that we have to add 3 times of OH minus, but this should be on both the side. Let me give you an example. In this case 3 times of H plus is present on the right hand side, so therefore I will add 3 times of OH minus ion both, that is on left hand side as well as on right hand side. So let us do it. So ultimately we will get an answer as, or we could derive, or we could balance the equation as 2 times of Zn plus NO3 minus plus 9 times H2 has given us NH3 plus 2 times ZnOH 6 2 minus plus 3 times H plus. So for that I will add 3 times OH minus ion on both the side. So ultimately I'll get an equation as 2 times Zn plus NO3 minus plus 9 times H2O. As I have mentioned, I have to add 3 times OH minus on the left hand side, which will give an answer of NH3 plus twice or 2 moles of ZnOH 6 times 2 minus plus 3H plus plus 3OH minus. So in this case, if you observe it very clearly, 3 times H plus and 3 times OH minus will make 3 moles of water molecule. So this 3 moles of water molecule can eliminate 3 mole of water molecule which is present in 9 moles of water molecule. So ultimately we'll get a final equation in which the OH which is present on the left hand side, and in this case OH is nothing but the basic solution, and therefore we are validating the balancing the redox reaction by adding OH minus ion, which is nothing but a basic solution or a basic medium reaction. So therefore this 3 times H2O will cancel out this 9 times among this 9 times H2O, and we'll get an answer as 2 times zinc plus NO3 plus 9 minus 3. This will give an answer of 6 times H2O. Therefore 6 times H2O plus 3 times OH minus will give an answer of, or will give a product of NH3 twice ZnOH 6 2 minus, and that's it. So eventually we have calculated, determined, or we have balanced the above equation in a basic medium. So this is the balanced equation. So thank you friends for watching this video. I hope you have liked this video and you have got how to balance this kind of the equation in basic medium. So don't forget to subscribe and share with your friends to Ekeeda channel. Thank you so much.